Very warm welcome to my YouTube channel Manish Mahabihar. Today I am going to discuss the solution of JEE Main 2025 January session of physics question paper. So my first question is question number 26. This question paper is downloaded from NTA official website. My first question: a war magnet has total length 2L equal to 20 units and the field point P is at distance D equal to 10 units from the center of the magnet. If the relative uncertainty of length measurement is 1%, then uncertainty of the magnetic field at a point P is. As you can see, this is bar magnet. This one is North Pole and here is South Pole. Length of magnet 2L, given 2L equal to 20 units. This is equatorial point and perpendicular bisector line. This one is known as axial point. For finding the uncertainty of magnetic field at point P, first we have to find the value of magnetic field at point P. Those values are given, we have written here, given 2L equal to 20 units. From there we calculate L 10 units. We have given D equal to 10 units and also given relative uncertainty of length measurement 1%. This means delta L YL equal to 1%. We have to find relative uncertainty of magnetic field, that is delta B by B. The magnetic field due to a short bar magnet at an axial point is given by the formula B equal to mu naught by 4 pi 2m by d cube, where m is magnetic dipole moment. Magnetic field due to a short bar magnet at an axial point is given by this. Magnetic field here mu naught by 4 pi 2m. This all is constant term and magnetic field only depends inversely proportional to cube of distance. Therefore, we find relative uncertainty of magnetic field delta B by B equal to magnetic field. As we see, magnetic field inversely proportional to cube power of d cube. Therefore, we say delta V by B 3 delta D by D. And we have given delta D by D 1%. Therefore, we find delta V by V equal to 3%. The answer of this question is 3%. In this question, we have to first remember the formula of magnetic field due to a short wire magnet at an axial point. B equal to mu naught by 4 pi 2m by d cube. Now moving to next question. Next question is matching type. We have list 1 and list 2. List 1, we have given 4 physical quantities named angular impulse, latent heat, electrical resistivity, electromotive force, and list 2 their dimensional formula. Dimensional, also known as dimensional symbol. First, we have angular impulse. Angular impulse, as we know, angular impulse change in angular momentum. Linear impulse change in linear momentum. So dimensional formula of angular impulse equal to dimensional formula of angular momentum. And we have find dimension of angular momentum. First, we write the formula of angular momentum. As we know, angular momentum, moment of linear momentum. Moment of linear momentum, it means r cross p, where r is position vector, p linear momentum. As we know, p equal to mv, mass into velocity. Therefore, we get the formula of angular momentum equal to mvr. And dimensional formula of angular momentum, we put the formula of m, mass, velocity, lt minus 1, and distance r, l. And after simplifying, we get dimensional formula of angular momentum, ml square, t minus 1. Now, our next physical quantity, latent heat. Amount of heat energy Q observed or released per unit mass during a phase change is known as latent heat. That is latent heat equal to amount of heat energy observed via release divided by mass. To get the dimensional formula of latent heat, we first use the dimensional formula of heat energy and divide by mass. Heat energy dimensional formula is same as kinetic energy because all type of energy, either kinetics and potential energy or heat energy, has same dimensional formula. For simplicity, we use kinetic energy formula half mv square, and here we put energy dimensional formula. M for mass, velocity Lt minus 1 and a square L square T minus 2 and divided by mass. And after simplification this, we get latent heat L square T minus 2. Here mass is not, therefore we write dimensional formula of latent heat m to the power 0 L square T minus 2. Now our next physical quantity, electrical resistivity. This is represented by symbol rho. As we know, formula of resistance R equal to rho into Lya. After arranging this, we get rho equal to R into AYL. To get the dimensional formula of resistivity, we have to find dimensional formula of resistance area length, where area dimensional formula L square length L. We have to find major challenge here to find dimensional formula of resistance. And we know by Ohm's law, V equal to IR, where V voltage, I current, R resistance, and R equal to V by I, voltage. If voltage and I, and we also know work done, charge into voltage. If we multiply charge into voltage, we get work done. From there, we get voltage V equal to work by charge, and work force into displacement, and force mass into acceleration into displacement. Current Q equal to IT, charge Q equal to IT, where I is current, T time. If we put the dimensional formula of mass, acceleration, distance, current, time, we get the dimensional formula of voltage. M for mass, acceleration Lt minus 2, D for distance L, current ampere, T for time. And after simplifying this, we get M L square T minus 3 divided by A. Thus, dimensional formula of voltage M L square T minus 3 A minus 1. Now, dimensional formula of resistance, dimensional formula of voltage divided by dimensional formula of current. We have find dimensional formula of voltage, this one. We put this value here, M L square T minus 3 A minus 1 divided by A. And after simplifying this, we get dimensional formula of resistance M L square T minus 3 A minus 2. Beginning of this question, we have derived the formula of resistance, resistivity rho equal to R A by L. Now we have put the value of dimensional formula of resistance R, ml square T minus 3 A minus 2, area L square divided by length L, and after simplifying we get dimensional formula of resistivity ml square T minus 3 A minus 2. Our next question, electromotive force. Electromotive force is equivalent to potential difference या voltage. Dimensional formula of electromotive force, and we have to find dimensional formula of voltage. And as we know, voltage work done by charge, work done force into displacement, force mass into acceleration, mass का dimensional formula है, acceleration का Lt minus 2, displacement का L, charge, current into time I, current AT, and after simplifying this we get M L square T minus 3 A minus 1. Thus we get dimensional formula of all these four physical quantities. Now moving to question, we get dimensional formula of angular impulse ml square T minus 1, latent heat m0 L square T minus 2, electrical resistivity m LQ T minus 3 A minus 2. So correct answer is option number 3, A cut 3, B1, C4, D2. Now we have to move Move next question. Question number 28. This question is written in Hindi medium. Here we have to find distance traveled by object between time equal to 0 to time equal to 4 seconds. Here graph of velocity time graph is given. Those students who don't understand the question in Hindi language, for those we explain the question in English. This graph is velocity time graph, and here we have to find distance traveled by object between t equal to 0 to t equal to 4 seconds. As we know, velocity ds by dt, and after simplifying we get ds equal to v dt, and after integrating both sides we get integral ds equal to integral v dt, ds integral s equal to integral v dt. Integral sign represent area, s for distance. It means distance equal to area of velocity time graph. We have to find area between t equal to 0 to t equal to 4. We have to find area of velocity time graph between t equal to 0 to t equal to 4 seconds. And between t equal to 0 to t equal to 4, velocity time graph, first t equal to 0 to t equal to 2, this one is triangle AOP. Next one, rectangle ABQP. If for finding the value of distance, we have to calculate the value of area of triangle AOP plus area triangle ABQP. Distance, area triangle AOP and area rectangle ABPQ. And we know area of triangle half into base into height, and area of rectangle L into B. Triangle का base 2 unit and height 10 unit. Rectangle का length 2 unit, height 10 unit, and after simplifying this we get distance 30 meters. That is distance traveled by object between t equal to 0 to t equal to 4 seconds is 30 meters. Now moving to next question. Question number 29. Earth has mass 8 times and radius 2 times that of a planet. If the escape velocity from the Earth is 11.2 km per second, the escape velocity in km per second from the planet will be. First, we have to understand the escape velocity. Definition of escape velocity: to escape any object from any planet. To escape any object from any planet, total energy of object at that point must be greater than equal to 0. Yeah, in other words, we have to say that if energy of object at any point positive, then object escape from that planet. That is, total energy means sum of kinetic energy plus potential energy greater than equal to 0. And we know kinetic energy half mv square, potential energy minus g m by r greater than equal to 0. Where capital M mass of celestial body, a small m mass of object, r distance between celestial body and object. And after simplifying this equation, we get half mv square minus g capital M small m divided by r greater than equal to 0. V square by 2 minus gm by r greater than equal to 0. And after simplifying, v square by 2 greater than equal to gm by r, v square greater than equal to 2 gm by r, and v greater than equal to 2 gm by r. It means from this equation we get formula of escape velocity under root m by r, where capital M mass of celestial body. Now question given: mass of Earth 8 times mass of planet, radius of Earth 2 times radius of planet, and escape velocity of Earth 11.2 km per second. As we know, escape velocity Earth equal to under root 2 capital G capital M divided by r. Velocity, escape velocity planet 2g mass of planet by radius of planet. And from there we put Mass of planet, mass of Earth divided by 8, radius of planet, radius of Earth divided by 2. From this, we get mass of planet and radius of planet value in term of mass of Earth and radius of Earth and put here, and after simplifying, we get the value of escape velocity of planet. 1 by 2 under root 2 capital G m divided by r. 1 by 2 into, and we know escape velocity of Earth 11.2 kilometer per second, planet 5.6 kilometer per second. Escape velocity of planet 5.6 kilometer per second. Now moving to next question, question number 30. A uniform rod of mass 250 gram having length 100 cm is balanced on a sharp edge at 40 cm mark. A mass of 400 gram is suspended at 10 cm mark. To maintain the balance of the rod, the mass to be suspended at 90 cm mark is the given mass of rod 250 gram, length of rod 100 cm. As we know, this is uniform rod of mass distribution. Center of mass is at midpoint. Here we indicate center of mass, distance 50 cm from either end, and this rod is balanced at sharp edge at 40 cm mark. From this end, 40 cm marks balancing point of this rod. The uniform rod has mass 250 gram and length of 100 cm. Its center of mass is at 50 cm. Center of mass is here. To solve this problem, we need to apply the principle of moments of force, that is torque. As we know, principle of moment of force equal to torque. And also we know for rotational equilibrium of any object, sum of clockwise torque, sum of anti-clockwise torque about pivot point. Means pivot point means balancing point. As we know, moment of force into perpendicular distance. First we have to find moment of force of center of mass about pivot point. We now see here center of mass here and distance 250 gram. Rod mass, center of mass have mass 250 gram and distance 50 cm from this end. And if we wait for center of mass this, if we drag this center of mass, rod will move towards this, that is clockwise direction. So moment of force of center of mass about pivot point 250 is mass of rod and 10 distance center of mass point. This is pivot point and this is center of mass. Distance between balance point and center of mass is 10 cm. You got 40 cm and center of mass 15. This distance is 10 cm. Multiply 250 into 10 and direction of torque of center of mass what pivot point is clockwise direction. Now we have to find moment of force of 400 gram mass about pivot point. 400 gram mass is here from in distance 10 cm, and this 400 gram mass distance between 400 gram mass and pivot point is 30 cm, and we drag this 400 gram mass, rod will rotate around this direction, means anti-clockwise direction, and in direction of moment of force is anti-clockwise direction. Distance between mass and pivot point 30 cm. Therefore, we get value of moment of force of 400 gram mass about pivot point is 400 into 30 anti-clockwise direction. Now, moment of force mass m suspended at 90 cm mark. We have to find the value of mass m that is suspended at 90 cm mark and mass object m suspended 90 cm mark. Now we see question. Mass m is suspended from this in 90 cm and distance is its pivot point and mass m is 50 cm because this one is 40 from this distance is 50 cm. I am being mass m drag this one direction of torque is clockwise direction if we about pivot point. The moment of force of mass m suspended at 90 cm mark equal to m and direction of moment of force clockwise direction. And earlier we have said for rotational equilibrium, anti-clockwise moment must be equal to clockwise moment. That is 400 gram into 30 cm equal to 250 gram plus into 10 plus m into 50. Clockwise we have add clockwise torque first and third and equal to anti-clockwise torque. And after simplifying this simple linear equation, we get 400 into 30, 12,000 equal to 2,500 plus 50 m, and after simplifying with this we get the value of a small m 190 gram. This one is answer. Our next question, question number 31. A body of mass 4 kg is placed on a plane at a point P having coordinate 3, 4 meter. Under the action of force F equal to 2I plus 3J Newton, it moves to a new point Q having coordinate 6, 10 meter in 4 seconds. The average power and instantaneous power at the end of 4 seconds are in the ratio of. In this question, we have given mass of body 4 gram and force vector F equal to 2I plus 3J Newton. When force act on body of mass 4 gram, object moved from point P to point Q in t equal to 4 seconds. We have to find the ratio of average power to the instantaneous power. And we know power equal to work by time and work force into displacement. So first we have to find displacement vector. This one is average power formula. And for calculating instantaneous power, formula of instantaneous power is dot product of force and velocity vector. It means for calculating instantaneous power, we have to find velocity vector. Now let us displacement vector D is simply difference of position vector Q minus position vector P. Displacement vector D equal to RQ minus RP. Position vector Q 6, 10. It is written as 6I plus 10J. Position vector P coordinate of P are 3, 4. Position vector of P is written simply 3I plus 4J. And subtracting this, we get displacement vector D 3I plus 6J. We have given force F 2I plus 3J. And we know power, work by time, work, force, dot product of force vector and displacement vector divided by time, we get average power. Force vector written 2I plus 3J dot 3I plus 6J, and we know dot product coefficient of I multiplied with coefficient of I, coefficient of J with multiplied with coefficient of J, 2 into 3 plus 3 into 6 divided by 4, and after simplifying this, we get average power value 6 watt. Now we have to find instantaneous power. Instantaneous power force dot product of force vector and velocity vector. And we know according to Newton's second law, force F is equal to ma. And acceleration, where m mass, a acceleration F by m. We have given force vector 2I plus 3j divided by mass, we get acceleration. Acceleration 0.5I plus 0.75j. We named the acceleration equation 1. Now we have to find the value of velocity of object at t equal to 4 seconds. We know simple kinematic equation of velocity v equal to u plus at. Initial velocity 0, acceleration 2I plus 3j divided by 4 times 4. And after simplifying, we get velocity vector 2I plus 3j. And instantaneous power, force dot velocity, force vector 2I plus 3j, velocity vector 2I plus 3j, and after taking dot product, we get 2 into 2, 3 into 3, 13 watt. Ratio of average power to instantaneous power 6 by 13 is the answer. Now moving to next question. Question number 32. A balloon and its content having mass capital M is moving up with an acceleration a. The mass that must be released from the content so that balloon start moving up with acceleration 3a will be. Take g as acceleration due to gravity. We have given a balloon whose mass is m. Balloon is moving upward towards acceleration a, and we know when any balloon moves towards upward, two type of force act on this balloon. एक weight force, force due to gravity mg, and another one is buoyancy force fb. And we have to find the, from this balloon, we assume a small m mass released. When a small m mass released from this balloon, mass of remaining balloon becomes capital M minus a small m, and this balloon now moves with acceleration 3a. And again, after this new situation, balloon again have two type of force. One is weight force and another is buoyancy force. Weight force capital M minus a small mg and buoyancy force fb. We indicated simply. Now we have written weight force mg. We correct here capital mg. Weight force mg. Weight force equal to capital mg. Buoyancy force fb. Net force. Balloon is moving towards upward direction with acceleration a. So net force mass into acceleration according to Newton's second law. Net force, buoyancy force, difference between weight force ma. From this we get buoyancy force value capital Ma plus capital Mg. Now again applying Newton's second law in second case. First we assume let a small m be the mass released from the content. The new mass of balloon and its content become capital M minus a small m. And again Newton's second law. Net force here again buoyancy force minus weight force. Buoyancy force minus weight force equal to mass into acceleration. Now balloon is moving with 3a acceleration. From equation 1 we put the value of buoyancy force capital A, capital Ma plus capital Mg, and after simplifying this equation we get value Ma plus Mg equal to 3 capital Ma minus 3 small ma. Moving capital Ma towards right hand side, and after simplifying this we get a small mg 2 capital Ma minus 3 ma. A small m term taken together for this minus 3 ma bring to LHS a small mg plus 3 ma equal to 2 ma. Taking a small m common m common g plus 3a 2ma, and we get finally value of a small m 2ma y g plus 3a answer. Now moving to next question. A 400-gram solid cube having an edge of length 10 cm floats in water. We have given a cube whose mass 400 gram and length of 10 cm float in water. How much volume of cube is outside the water? For this we have to first find volume of cube, and volume of cube immersed in water. Volume of cube, as you know, side into a cube, zero point 0.1 into 3 meter cube. Volume of cube we get 0.001 meter cube. Mass of cube given 400 gram, 0.4 kg. Now we have calculate density of cube. As we know, density mass by volume, mass of cube divided by volume of cube. We have written symbolic form. Density of cube, mass of cube divided by volume of cube, we will get density of cube 400 kg per meter cube. And now, according to principle of flotation, for an object floating in a liquid, any object that floats in liquid, the buoyancy force must be equal to weight of an object. That is, weight of displaced water equal to weight of object. And weight of displaced water, weight volume into density, means density of water into volume immersed into G, acceleration due to gravity, equal to weight of object, volume of cube into density of cube into G. From this equation we get volume of cube, that is immersed in water, density of cube into volume of cube divided by density of water. And after putting the value of density of cube, volume of cube, density of water in SI unit, we get volume of cube, that is immersed 0.0004 meter cube. Now we have find volume of cube outside the water. Volume of cube minus volume of cube immersed in water. Volume of cube 0.001 meter cube, volume of cube immersed in water 0.0004 meter cube, and after simplifying this we get volume of cube outside the water equal to 6 into 10 to the power 2 centimeter cube, that is 600 centimeter cube. This one is the answer of this question. Now our next question is question number 34. The kinetic energy of translation of the molecules in 50 gram of CO2 gas at 17 degrees Celsius. We have to find kinetic energy of molecules of CO2. We know translational kinetic energy of molecule in a gas, translational kinetic energy 3 by 2 nRT, where n is number of mole, R ideal gas constant, whose value is 8.31 joule per mole Kelvin, T temperature in Kelvin. So here first we have to find number of mole of CO2. As we know, number of mole of CO2, mass of CO2 divided by molecular weight of CO2. Mass of CO2 given 50 gram and weight of CO2 44 gram. And after simplifying we get number of mole of CO2 1.136 mole. We have given temperature 17 degrees Celsius, converting it into Kelvin, we add 273.15, we get temperature 290.15 Kelvin. Now applying formula of transitional kinetic energy 3 by 2 n. N here is number of mole, R gas constant, temperature, and after solving this we get 4102.8 joule. And the answer of this question is 4102.8 joule. Now moving to next question. The ratio of vapor density of two gases at the same temperature is 4 by 25. Ratio of vapor density, ratio of root mean square velocity will be RMS means root mean square velocity. First we have write formula of root mean square velocity under root 3 RT by m, where R is gas constant, T is temperature, and m is molar mass. We know vapor density D is related to vapor mass. Vapor density Vd is related to molar mass m of a gas. Molar mass 2 into vapor density. It means molar mass directly proportional to vapor density. Ratio of molar mass of gas, ratio of their vapor density. That is m1 by m2 equal to vapor density 1 by vapor density 2. We have given ratio of vapor density to gas 4 by 25. It means molar mass ratio is also 4 by 25. Now applying the formula of root mean square velocity of two gases, RMS velocity 1 divided by RMS velocity 2 under root 3 RT by M1 under root 3 R2 by M2. Under root 3 RT, under root 3 RT, upper portion is cancelled and rest is under root M2 by M1. After simplifying this, we get RMS velocity 1 by RMS velocity 2 equal to M2 by M1. Here M1 by M2 4 by 25, and after interchanging numerator and denominator, we get M2 by M1 25 by 4, and after solving we get ratio of RMS velocity of gas 1 to gas 2 5 by 2 is the correct answer. Now moving to next question. Question number 36. This question is assertion region tab. Here two statements are given. One is assertion and other is region. Assertion statement is knowing initial position x0 and initial momentum p0 is enough to determine the position and momentum at any time t for a simple harmonic motion with a given angular frequency omega s. This is true. If we know initial position and initial momentum, then by using equation of simple harmonic motion, we find position and momentum at any time t of simple harmonic motion. If initial condition is known, everything is known. So assertion A is true. Next question. Amplitude and phase can be expressed in terms of x0 and p0. Yes. Amplitude is denoted x0 and phase is p0. Here we have written equation of motion of simple harmonic motion x equal to a sine omega t plus phi. Here a is amplitude, omega angular frequency, phi phase difference, t time. And if we know initial position and initial momentum, we know the position of and momentum any time t. So assertion A is true, R is true, and R is correct explanation of assertion. So correct answer is here option number A. Now moving to next question, question number 37. A parallel plate capacitor of capacitance 1 microfarad is charged to a potential difference of 20 volt. The distance between the plate is 1 micrometer. The energy density between the plate of capacitor. We have given a parallel plate capacitor. Each capacitance is 1 microfarad, charged to a potential difference V volt. This one is charged to a potential difference V volt. Distance between plate 1 micrometer. Energy density between plate of capacitor we have find. Energy density between plate of capacitor. Formula of energy density between plate of capacitor is half epsilon naught ES, where E is electric field, epsilon naught is constant term, relative permittivity of in free space, and we know electric field V by D, V voltage by distance. From putting this Value of electric field in this formula, we get capacitor energy density half epsilon naught V square by d square, and we know epsilon naught value, 8.85 into 10 to the power minus 12 SI unit. We put here voltage, we have given 20 into 20 divided by d square, d distance between plate 10 to the power minus 6, 10 to the power minus 6, and after simplifying this simple calculation, we get the value of energy density between plate of parallel plate capacitor is 17.7 into 10 to the power 2 joule per meter cube, and approximate value is 1.8 into 10 to the power 3 joule per meter cube. Now moving to next question, question number 38. An infinite bar has a circular bend of radius a and carrying a current I as shown in figure. The magnitude of magnetic field at the origin O of the arc is given by. Here is semicircular arc and current I is following this arc. We have to find magnitude of magnetic field at point O. For this we have to find, we divided this arc is three parts. Part one is this one, a straight wire. Second one is circular, and third one is from this straight wire, infinite bar. And now we have find the value of magnetic field separately in three parts. First, a straight wire which is passing through point O. Second, circular arc which makes angle 3 pi by 2 at center. Third, a straight wire which is perpendicular distance from center and wire is a radius of arc. As we know, we written this process. The magnetic field at the origin O is due to three parts of wire. First, a straight infinite wire segment to the left of bend. Second, semi-circular arc. And third, the straight infinite wire segment to the right of the bend. According to Wiot-Savart law, V equal to mu naught by 4 pi I dl cross R by R cube. V equal to mu naught by 4 pi I dl R sin theta by R cube, and after simplifying we get mu naught by 4 pi I dl sin theta by R square. We have theta angle between position vector R and current direction. From this formula we get, if direction of current and position vector are in same line segment, then magnitude of magnetic field equal to 0. That is first part. First is a straight wire, infinite wire passing through origin, magnetic field from part 1 0. Second one, semicircular arc which makes angle 3 pi by 2 at center. As we know, circle makes 2 pi angle at center, and it is 3 quadrant of circle, 3 pi by 2. And formula of magnitude of magnetic field due to semicircular arc is mu naught by 4 pi I by r theta, where I is current, r radius of arc, theta angle of arc made at the center. This one is formula of magnitude of magnetic field due to semicircular arc, mu naught by 4 pi I by r theta. Now we put value of r and theta in this formula. Mu naught by 4 pi I radius equal to a and angle 3 pi by 2, and after simplifying we get 3 pi mu naught I 8 pi a. Now third part, a straight infinite wire which is perpendicular distance from origin is a, and formula of finding magnitude of magnetic field due to infinite wire is mu naught by 4 pi I by x, where x is perpendicular distance from wire to point, and sin alpha plus sin beta, where alpha and beta angle made by this perpendicular distance to both sides of wire. This was is infinite wire, so beta equal to 90, and here is perpendicular alpha equal to 0, and after putting this we get value of magnetic field mu naught by 4 pi I by a. A is perpendicular distance sin alpha 0, because this direction, perpendicular direction and in are same. Sin alpha 0, sin beta 90, because this side is infinite wire. And after simplifying this, we get value of magnetic field to third part of arc is mu naught I by 4 pi a. Now magnetic field total value by adding all the three parts, mu naught by 4 pi I by a, 3 pi by 2 plus mu naught by 4 pi I by a. First, second, third part. First part is 0, and after simplifying we get value of magnetic field due to semicircular arc is mu naught I 4 pi a, 3 pi by 2 1. This one is answer of this question. Now moving to next question. Now our next question is question number 39. A uniform magnetic field of 0.5 Tesla X perpendicular to a circular copper disc 20 cm in radius. The disk is having a uniform angular velocity of 10 pi radian per second about an axis through its center and perpendicular to the disk. What is the potential difference developed between the axis of the disk and the ring? In this question, we have given a circular copper disk of radius 20 cm, an uniform magnetic field 0.5 Tesla, x perpendicular to disk, and angular velocity of copper disk is 10 pi radian per second. We have to find potential difference developed between the axis of disk and ring. As we know, when any body, any object moves or rotates in a uniform magnetic field, then due to motion of object, flux is changed, and due to flux change, magnetic flux changes, and EMF potential difference is developed. That potential difference we have to find. For this, we consider a small element dr at distance r from center. As we know, motional EMF, that is EMF produced due to motion of object in magnetic field, is BVL, where V is magnetic field, here B is magnetic field, V is velocity, and L is length. This is the formula of motional EMF produced due to the motion of object in magnetic field. Another form of this formula we have written for a small element dE v cross v dot dr. As we know, velocity v equal to omega r. Therefore, dE vb dr. This is the formula of motional EMF. Here E for EMF, v is velocity, b magnetic field, dr distance. We put v equal to omega r b dr. Taking integration on both sides, we get integral dE equal to integral. We have to find potential difference developed between center and rim. That's why limit of integration is taken r0 to r capital R. B omega r dr. Here B is constant, omega angular velocity constant term taken out from the integral. We get motional EMF E B omega 0 to capital R r dr. And after integrating r, as we know, r integration r dr integral r square by 2 because integral x to the power n into dx equal to x to the power n plus x divided by n plus a. This is the formula of integration. By using this property, we integrate 0 lower limit 0 to upper limit capital R r dr. We get r square by 2 0 to r, and after putting the upper limit and lower limit in this bracket, we get motional EMF half b omega r square. Now put the value of magnetic field V, angular velocity omega, and radius r. Magnetic field 0.04 Tesla, omega 10 pi, angular velocity 10, pi की value 10.14, 3.14, radius 20 cm, in SI unit 20 into 10 to the power minus 2, 20 into 10 to the power minus 2, radius का square. And after simplifying this simple arithmetic calculation, we get the value of motional EMF equal to 25.12 into 10 to the power minus 2 volt. And answer is from option EMF 0.2512 volt. This one is the answer of this question. Now moving to next question. Question number 40. The magnetic field of electromagnetic wave is given by B equal to root 3 by 2i plus 1 by 2j 30 sine omega t minus z by c SI unit. Corresponding electric field in its SI unit. In this question, we have given magnetic field vector of electromagnetic wave, and we have to find electric field. As we know from this argument of sine wave zyc, negative sign indicate that wave traveling in positive z direction. Here I and unit vector I and j indicate that magnetic field in xy plane, and this magnetic field is moving traveling in positive direction. As we know, in electromagnetic wave, EMW is the short form of electromagnetic wave. In electromagnetic wave, the electric field vector E, magnetic field vector V, and direction of propagation are mutually perpendicular. That is, direction of propagation vector K is direction of propagation vector. Yeah, we can say K is propagation vector directly proportional to E cross B. As we know, ratio of amplitude of electric field to the magnetic field gives the speed of light in vacuum. In this formula, we get electric field CB naught. In question, magnitude of magnetic field given 30. This one is the plane of magnetic field, and this sine omega t minus z by c indicate motion of electromagnetic field wave. Here magnitude of magnetic field 30 unit. Therefore, we find magnitude of electric field 30 C unit, where C is speed of light. Here C indicate a speed of light. Here c indicate a speed of light in vacuum. We need a vector electric field E. We have assumed electric field vector E, Exi, Eyj such that we know dot product of electric field vector and magnetic field vector 0. Now we have take dot product of electric field vector and magnetic field vector Exi plus Eyj under root 3I half j equal to 0. After taking dot product, it is multiplying the coefficient of I with I, Ex root 3 by 2, Ey half j. We get linear equation in two variable under root 3 Ex plus Ey equal to 0, Ey equal to minus root 3 Ex. Also, the magnitude of electric field we earlier stated E naught. As we know, Ex square equal to E naught, and this E naught equal to under root Ex square plus E by a square. From here we rewrite the equation Ex का whole square plus E by का whole square equal to E0 E naught का whole square, and putting the value of Ey equal to minus root 3 Ex. And after simplifying this, we get Ex square plus 3 Ex square equal to E0 का whole square, 4 Ex का square, E naught का whole square, and after simplifying we get value of Ex plus minus E naught by 2. That is Ex have two value plus minus E naught by 2. If we take Ex plus E naught by 2, we get Ey minus root 3 by 2 E naught. Then electric field E0 up I minus under root 3 by 2j. If we take Ex minus root 3 by 2 is negative sign, then Ey under root 3 by 2 E naught. Then electric field vector E0 minus half I plus root 3 by 2j. From equation 1 and 2, we write equation of electric field electromagnetic wave E. As we know, E बराबर C being sin omega t minus z. E बराबर C 1 by 2I minus under root 3 by 2j B naught sin omega t minus z by C. And from equation 2, electromagnetic wave electric field vector of electromagnetic wave is C minus half I plus under root 3 by 2j B naught sin omega t minus z by C. This is the answer of electric field vector of electromagnetic wave, whose magnetic field is given. Now, our next question is question number 41. In a long glass tube, mixture of two liquids A and B with refractive indices 1.3 and 1.4 respectively form a convex refractive miniature towards A. If an object placed at 30 cm from the vertex of miniature in A form an image with magnification of equal to -2, then the radius of curvature of miniature is. In this question we have given a long glass tube in which mixture of two liquids A and B with refractive index 1.3, 1.4 is filled and convex refracting miniature towards A. Here we make diagram of this question. This is long glass tube towards A convex reflecting surface. This one is A and it towards A surface is convex. We indicate here convex reflecting surface towards A, refracting index of liquid A 1.3, refractive indices of 1.4, magnification -2. An object is placed 30 cm distance from reflecting surface. We have to find radius of curvature of miniature. Radius of curvature of miniature in this question given magnification equal to -2. -2 magnification with negative sign indicate image is inverted. Negative signs indicate image is inverted, and size of Absolute value of magnification 2. It means size of image 2 times the size of object. As we know, magnification equal to image distance by refractive index, index object distance by refractive index. Image distance symbol is V by mu 2, U by mu 1. We have given magnification minus 2, M equal to minus 2. Image distance we have not known. We simply put V. Refractive index, where that place image is formed, that is refractive index of medium 2, 1.4. Object distance U minus 30 with proper sign convention. U minus 30. Object and refractive index of object side medium 1.3. 13 by 1.3, that's why 1.3 is written in numerator term. And after simplifying this, we get the value of V in position of image. Position of image 28 cm. For this magnification formula, we have find the position of image 28 cm. Now I am some give explanation of sign convention in image. Object distance is here. Direction of object towards reflecting surface is known as positive direction. Object is here, reflecting surface is here. But this direction is positive direction. And any distance measured towards this direction is taken as positive direction, and any distance that is measured opposite to this direction is written as negative direction. That's why object here, reflecting surface is here. Object distance is measured from this to this direction. That's why U is minus 30. Image is measured from this to this V. That's why V is positive, because direction of image is towards the direction of ray emerging from object. This is the rule of sign convention used in mirror problem. Now we have applied lens maker formula for single refracting surface. As we know, lens maker formula, refractive index by image distance minus refractive index by object distance equal to difference of refractive index by radius of curvature. Because we have to find radius of curvature, or for this we have applied the lens maker formula. And after putting the value of mu 2 1.4, V 28, mu 1 1.3, U minus 30. U is minus 30 with sign convention. Mu 1.4 1.3 radius, and after simplifying this, we get 1 by 20 plus 1 by 10 equal to 0.1 by r. And after equating the solving this equation, we get value of r radius of curvature 2 by 3 cm. That is 2 by 3 cm is the answer of this question. Now moving to next question. Question number 42. A concave mirror produces an image of an object such that distance between the object and image is 20 cm. If magnification of image is minus 3, the magnitude of radius of curvature of the mirror. Here once again we have to find radius of curvature of mirror. We have given concave mirror and distance between object and image. That is modulus of u minus v 20 cm, magnification of image minus 3. Magnification minus 3, negative sign indicates that image is inverted. And this numerical value 3 indicates that size of image 3 times the size of object. We draw a concave mirror, this one, and concave mirrors image inverted and large form when object is between center of curvature and focal length focus. In concave mirror, when object placed between center of curvature and focus, image is formed inverted and enlarged. Center of curvature, same size of image is formed and inverted. Between center of curvature and focus, image is inverted and enlarged. We have given magnification -3, and we know magnification formula for mirror minus V by U. -3 minus V by U, we get V equal to 3. As we know, V minus U, here V is large distance U, this one is U, this one is V, and both are negative because in mirrors, object is here, mirror is here. Object to mirror direction, ray is emerged towards this direction. This direction is positive direction. Distance measured against this direction is negative. Here U negative, V negative. V minus U 20. V we have find 3U, putting the value of V equal to 3U, and after solving this we get U 10 cm and V 30 cm. Thus we obtained value of U and V. And now applying sign convention for a concave mirror, U minus 10, V minus 30. Applying sign convention for a concave mirror, U minus 30, V minus U minus 10, V minus 30 cm. Now using mirror formula is 1 by V plus 1 by U equal to 1 by F. This one is mirror formula. Put the value of V minus 30, U minus 10, and solving this equation, we get value of focal length F minus 30 by 4, F minus 7.5 cm. And we know radius of curvature is 2 times the focal length, R equal to 2F. This is another formula for mirror, and putting the value of focal length and after calculating we get radius of curvature value minus 15 cm. A magnitude of radius of curvature of concave mirror is 15 cm is the answer. Now moving to next question number 43. This question is written in Hindi medium. We explain this question in English. In this question we have to find frequency of an electron revolving around Bohr orbit is what proportion to quantum number n, and we have to find frequency of electron in nth Bohr orbit. As we know, formula of frequency of electron in nth Bohr orbit is z square e to the power 4m 4 pi square epsilon naught का whole square h q y n q. Here z is atomic number, m is mass of electron, e is charge of electron, epsilon naught is relative permittivity of in vacuum, h Planck's constant, n quantum number. From this formula be seen frequency inversely proportional to 1 by nq. So correct answer is option number 1 by nq. Now our next question number 44. Which of the following phenomena cannot be explained by wave theory of light? Here four phenomena is given: reflection of light, refraction of light, diffraction of light, Compton effect. And we have to ask which phenomena is not explained by wave theory of light. As we know, reflection, bouncing back of light when it strikes a surface is known as reflection, and it is explained using Huygens principle of wave theory of light. Refraction of light, the definition of refraction is bending of light when it passes from one medium to another is known as refraction, and it is also explained by wave nature of light. Diffraction is a spreading of light wave as they pass through an aperture around an obstacle. When a light wave is passed through a small aperture, which size is wavelength of wave, yeah, when a light wave passes through an obstacle where a spreading of light wave is known as diffraction, and it is clear demonstration of wave nature of light. Next one is a Compton effect. Compton effect involves the scattering of X-ray by electron, result in change in wavelength of scattered X-ray. This phenomena cannot be explained by the classical wave theory of light, and this requires the concept of light as discrete particle, photon, with momentum. That is, to explain Compton effect of light, we must need discrete particle. Therefore, Compton effect cannot be explained by wave theory of light. So answer is Compton effect. Now moving to next question. Question number 45. In the circuit shown here, assuming threshold voltage of diode is negligibly small, the voltage VAB is correctly represented by, here one circuit is given, here AC voltage V equal to sin omega t, here is diode, threshold voltage of diode is negligibly small. Threshold voltage of diode is negligibly small, this means diode is ideal diode. And one resistance in series, we have to find here graph of output voltage VAB, given input voltage V0 sin omega t. Diode and resistor in this circuit are in series. Diode and resistor are in series. For AC voltage, as we know, forward bias, when input voltage positive, output voltage V0 sin omega t. For reverse bias condition, that is when input voltage negative half of the cycle, in this case, circuit is open and current 0, that is output voltage 0. From this concept of forward bias and reverse bias diode, we arrive at a conclusion voltage V across the resistor non-zero during the positive half cycle of input voltage, and voltage V equal to 0 across the resistor during negative half cycle of input voltage. So graph of output voltage is option number 2, non-zero positive half cycle, 0 negative half cycle, positive again during positive half cycle. So option B, option number 2, this one is the correct answer of output voltage of this question. Now our next question. The volume contraction of a solid copper cube of edge length 10 cm when subjected to a hydraulic pressure of 7 into 10 to the power 6 Pascal would be, given Buck modulus of copper is equal to 1.4 into 10 to the power 11 Newton meter. We have given a solid copper cube of edge length 10 cm, that is edge length 0.1, hydraulic pressure P 7 into 10 to the power 6 Pascal, Buck modulus of copper 1.4 10 to the power 11 Newton by meter square. We have to find volume contraction of solid copper. For this, we use the formula of Buck modulus of copper. Volume of cube, as we know, a cube varies side length. Putting the value of 8.1 meter, we have find volume of cube is 0.001 meter cube. Buck modulus B is defined as minus P by changing volume to original volume, initial volume. Here P is pressure, delta V change in volume, V initial volume. This is the formula of Buck modulus. In this formula, we have Buck modulus is known, pressure is known, volume of cube we have find. From after putting this value of Buck modulus, pressure, initial volume, we have find the volume contraction, that is change in volume delta V. After arranging this equation, volume contraction delta V equal to minus P V by D. Now put the value of pressure 7 into 10 to the power 6, volume of cube 0.001 meter cube, and Buck modulus 1.4 into 10 to the power 11. And after simplifying this simple arithmetic, we get value of delta V minus half into 10 to the power 6 divided by 10 to the power 13 meter cube. minus 0.5 10 to the power minus 7 minus 5 10 to the power minus 8 meter cube. As we know, 1 meter equal to 1000 mm cube minus 5 10 to the power minus 8 into 10 to the power 9 millimeter cube. And after simplifying this, we get change in volume equal to minus 5 into 10 millimeter cube minus 50 millimeter cube. Minus sign indicates contradiction of volume. So answer of this question is minus 50 millimeter cube. Now moving to next question. Question number 47. An electric dipole of dipole moment 6 into 10 to the power minus 6 cm is placed in uniform electric field of magnitude 10 to the power 6 volt per meter. Initially, the dipole moment is parallel to electric field. The work that needs to be done on dipole to make this dipole moment opposite to field will be. In this question, a dipole given has been dipole positive sign negative, and direction of positive to negative direction of dipole moment. We have given value of dipole moment 6 into 10 to the power minus 6. Initially, electric field direction is parallel to dipole moment direction. Dipole moment direction parallel to electric field direction, and magnitude of electric field is given 10 to the power 6 volt per meter. We have to find value of work done. Dipole moving dipole moment direction opposite to electric field direction. It means we have to rotate this dipole in 180 so that direction of electric field here towards right, and if we rotate this dipole 180, plus sign is right, negative minus sign is left, we get direction of dipole moment and direction of electric field are opposite to each other. For this we have to move the dipole moment, moves the dipole towards 180 degree. And as we know, work done W in rotating an electric dipole for an initial angle theta 1 to final angle theta 2 in uniform electric field is given by work done P into E cos theta 1 minus cos theta 2. Here P is electric dipole moment. This one is formula. Here P is dipole moment. Now our next question is question number 47. An electric dipole of dipole moment 6 into 10 to the power minus 6 capacitance meter is placed in a uniform electric field of magnitude 10 to the power 6 volt per meter. Initially, the dipole moment is parallel to electric field. The work that needs to be done on the dipole to make its dipole moment opposite to the field will be. In this question, we have given a dipole whose dipole moment is 6 into 10 to the power minus 6 capacitance meter. Magnitude of electric field 10 to the power 6 volt by meter. Initial direction of dipole moment and direction of electric field are same, parallel. As we know, direction of dipole moment is direction of positive charge to negative charge. Positive charge to negative charge is direction of dipole moment, and initially dipole moment and electric field are parallel. That is, they are in same direction. We have to find the value of work done to make direction of dipole moment and electric field are opposite. For this, we have to rotate the dipole by 180 degree. When we rotate this dipole by 180 degree, then direction of dipole moment reverse. In second picture, we have rotated this electric dipole by 180. Positive sign is right side, negative sign is left side. In this way, direction of dipole moment are towards left and electric field are towards right. That is opposite to each other. For this, we have to rotate the dipole by 180 degree. And we know the work done W in rotating an electric dipole from an initial angle theta 1 to final angle theta 2 in a uniform electric field is given by work done PE cos theta 1 minus cos theta 2. This is the formula of finding work done. for rotating the electric dipole. Pe cos theta 1 minus cos theta 2, where P is dipole moment, E electric field, theta 1 initial angle between dipole moment and electric field, theta 2 final angle between dipole moment and electric field. Now put the value of dipole moment 6 into 10 to the power minus 6, electric field 10 to the power 6, theta 1 0, cos 0 minus final angle 180. As we know, cos 0 1 and cos 180 minus 1, and after simplifying we get the value of work done 12 joule. This is 12 joule is the answer of this question. Now our next question is question number 48. The value of current I in the electric circuit as given below, when potential at A is equal to potential at B will be. Here we have given a circuit, 40 volt battery is connected, I current follow this circuit. We have to find value of current I in this circuit and potential A equal potential of B. Potential of A equal to potential of B. It means current is 0 in this 30 ohm resistance. This is the condition of balance with a stone bridge. This is the condition of balance with a stone bridge, because when potential A B equal, no current can pass through this 30 ohm resistor. And we know for balance with a stone bridge, cross product of resistance, that is 10 ohm into 40 ohm equal to R into 20 ohm. This is the condition of balance with a stone bridge. 10 into 40 equal to R into 20. And cross product of resistor equal. And for this we find the unknown resistor R value, R equal to 20 ohm. Equivalent resistor of circuit, for finding current I, we have to find equivalent resistance of this circuit. Equivalent resistor of this circuit is, we have draw here diagram of equivalent resistor of this circuit. Circuit now becomes of this type. Here 10 ohm, 20 ohm, 20 ohm, 40 ohm. Upper portion of 10 ohm, 20 ohm resistor are in series. Lower portion 20 ohm, 40 ohm are also in series. 10, 20 add equivalent resistance 1 by R equivalent, and after that this one is parallel 1 by R1, 1 by R2. R1 10 plus 20, R2 20 plus 40, and after simplifying we get value of equivalent resistance R equivalent 20 ohm. And by Ohm's law we know V equal to IR, current I equal to V by R, voltage 40 volt and equivalent resistance 20 ohm. 40 divided by 20, current I 2. We also draw equivalent resistance figure of this 10 and 20. After adding, series become 30. 20 and 40 after adding up become 60 ohm. In series, resistor are simply added. This is the final diagram of our circuit. No 30, 60 are parallel. The parallel for formula 1 by R equivalent, 1 by R1, 1 by R2. Series simply add. Now our next question, question number 49. A conducting wire moves on two conducting rails as shown in figure. A constant magnetic field B exists into the page. It means direction of magnetic field inverts the page. The wire starts to move from vertex at time t equal to 0 with a constant velocity. Wire moves with constant velocity. If the induced EMF is T directly proportional to T to the power n, the value of n is. As we know, when any rod or wire moves in a magnetic field, there is change in flux, and due to this change in flux, EMF is induced. In this question, we have given, as we know, formula of velocity. Velocity is rate of change of position with respect to time. V equal to dx by dt. An object is moving with constant velocity. It means dx by dt equal to 0. When bar moves with constant velocity, its displacement from vertex will be proportional to time. It means x directly proportional to time. As bar moves, it encloses an area, and area enclosed by the wire and rails will be proportional to a square of displacement. Because also area is always multiplication of dimension of the length into breadth, side into side, area directly proportional to x square and x directly proportional to time. Therefore, we get area directly proportional to t square. And induced EMF E minus d phi by dt, where phi is magnetic flux. Phi is magnetic flux. And value of magnetic flux phi B into A. B magnetic field, A area. B magnetic field, A area. We put value of phi BA, and here area directly proportional to 2A square. Therefore, dA by dt directly proportional dA by dt. B is constant term is taken out of differentiation, minus B dA by dt, and area directly proportional to time square. We put A t square, and after differentiating we get EMF induced minus B 2t, and EMF induced directly proportional to time. And in this question given, induced EMF directly proportional to t to the power n. After comparing both this equation, we get value of n equal to 1 is the answer. Now our next question, question number 50. A thin transparent film with refractive index 1.4 is held on a circular ring of radius 1.8 cm. The fluid in the film evaporates such that transmission through the film at wavelength 560 nanometer goes to a minimum every 12 seconds. Assuming that the film is as flat on two sides, the rate of evaporation is pi into 10 to the power minus 13 meter cube per second. In this question, a transparent film of refractive index 1.4, radius of film 1.8 cm, and refractive index of film n 1.4 is given, and wavelength 560 nanometer. And question given, wavelength minimum every 12 seconds. That is minimum destructive interference. Minimum intensity interference is known as destructive interference at every 12 seconds. To determine the rate of evaporation, we first need to find the change in thickness of film. The condition for minimum transmission, that is destructive interference in a thin film, is given by 2nt equal to m lambda. Condition for minimum transmission in thin film is given by 2nt m lambda, where n refractive index of film, t thickness of film, m integer represent the order of minimum, lambda wavelength of light. Now determine the change in thickness of one minimum cycle. In this question given, when transmission goes to a minimum every 12 seconds, it implies a change in thickness corresponding to one order of interference. So if thickness changes from T1 to T2 in 12 seconds, and these correspond to consecutive minimum, then we have rate 2n T2 minus T1, that is 12 seconds, the thickness change 2n T2 minus T1 बराबर m plus 1 lambda minus m lambda. And after simplifying, we get delta T equal to T2 minus T1. Change in thickness delta T. T2 minus T1 is change in thickness. T2 minus T1 equal to lambda by 2n. And after putting the value of lambda and n, we get value of change in thickness 200 into 10 to the power minus 9 meter. Now we have to calculate volume of fluid evaporate per cycle. The film ion circular ring with radius r 1.8 cm equal to 1.8 10 to the power minus 2 meter. Area of film pi r square, pi 1 r square. Volume of fluid evaporated in one cycle, delta V. Delta V is volume of fluid evaporated in one cycle, and we know volume is area into thickness. Now we put the value of area and thickness, and simplifying this simple arithmetic, we get volume of fluid evaporated in one cycle, delta V, pi into 648 into 10 to the power minus 13 meter cube equal to 5 into 6.48 10 to the power minus 11. Now we have calculated final answer, calculation of rate of evaporation. Time taken for this evaporation 12 seconds. Rate of evaporation, volume evaporated by time. This is rate of evaporation. Now put the volume evaporated pi into 6.48 into 10 to the power minus 11 by time 12, and after simplifying this we get rate of evaporation equal to pi into 54 into 10 to the power minus 13 meter cube per second. So missing value in question rate of evaporation given pi into open space into 10 to the power minus 13 meter cube per second. So missing value in question is equal to 54. So that is the complete solution of this question paper of JEE Main 2025 physics paper. Thanks for watching.